Hi everyone, in this video we're running through the example we had from the previous video of having our bag full of marbles with 6 red marbles, 4 green marbles, they're all over here, 4 green marbles and 5 blue marbles. Right, we're going to put this to the side so it's easier for us to see, right, and so as we go along we can actually understand the question a little better. Of course, the discussion now surrounds some questions that we've come up with for us to discuss better. Right, first question, it says 2 blue marbles, right, so right, 1. And the way you write 2 blue marbles, you just write down P bracket B B. Right, the conjunction between is blue and then blue, right? So N is in the middle of them. So what we do is we're actually looking at this pathway over here, blue and then blue. So it's the one that's over here. First blue followed by second blue. Okay, so what the probability? We just take 1/3, 1/3. And then 2%, because n is just times, and this will give you 2 out of 21. Right? Next question, 1 blue and 1 red marble. So we can write our property as P, 1 blue, comma, 1 red. So what we're actually looking at for question part 2 is that we're looking at 1 blue and 1 red. There are 2 possibilities. It's these two over here, blue, red, and red blue, because both of them fulfill the condition of having 1 red marble and 1 blue marble. And actually we can have realized that there are 2 ways to find this out: blue followed by red, apologies, blue followed by red over here, and of course the other one is red followed by blue to achieve this pathway here. So you realize that there are 2 different ways, and we have to list them out as red, blue. And how do you list them out in the probability here? You join them with the word or red or blue red. So the first one is pathway number 1, it's pathway number 2, and that's why we have 1 and 2 different outcomes. So let's find our red blue. Red blue is actually just 2 out of 5 times 5 out of 14. 2 out of 5 times 5 out of 14, or is a plus 1/3 times 3 out of 7, and this will give you 1 out of 7 plus 1 out of 7, 2 out of 7. Okay. Next question. Find the probability of drawing marbles of the same color. So let's try this question. Okay, just bring everything down again. So marbles of the same color. 3. So there are 3 ways we can interpret or have this outcome. First of all, you have your red, red, you have your green, green, and blue, blue. And blue, blue has already been calculated for you. But before we do that, we have to list down the possible outcomes that will fulfill the criteria of having the same color. So P, red, red, or green, green, or blue, blue. Since we already have blue, blue from part I, we can put that down here all the way to back later. But before that, we just do our red, red. Red, red is 2 out of 5, and then red, so it's 5 out of 14. Or is a plus. Green, green, of course, is 4 out of 14, 4 out of 15 times 3 out of 14. 4 out of 15 times 3 out of 14 plus, and this is the answer we already have from part 1, which is plus 2 out of 21. So let's calculate this. 1 of 7 plus 2 plus 4 of 15 that's 3 of 14 plus 2 of 21, and you have 31 out of 105. 1 out of 105. Right? Let me just set up the board again. So these are the 3 mini questions, part 4, part 5, and part 6. Next one is marbles of different colors. So if you want to find marbles of different colors, you need to understand that there are only two possible mutually exclusive outcomes. It's either, when you draw two marbles, they're either the same color or a different color. And this is what I refer to as mutually exclusive outcomes. So there will be no overlap. So either the two marbles drawn are of the same color or different color. Once you have this particular relation, you can take it as 1 minus P, same color, which is the answer we have from our previous working. So it's 1 minus 31 out of 105 gives you 74 over 105. Right, very straightforward. Next, no green marbles. Part 4, part 5, no green marbles. For us to understand there are no green marbles with two draws, you can redraw the bag of marbles and reorganize them as either green or not green. So let's try our green marbles. We have 4 green marbles. And how many non-green marbles do we have? Let's take a look here. We have actually 11 non-green marbles. 11 non-green. So to fulfill the condition of no green marbles within the two marbles drawn, it is actually P, no green, no green. And of course, the connector here is a conjunction, is N. So the property of us drawing a non-green marble at the start is 11 out of 15, and then it is 10 out of 14. So let's calculate that. 11 out of 15. We have 11 out of 21. The next question, part 6, excuse me, they ask for at least one green marble, right? So that's what they want. P, at least one green. Over here, we realize they actually share the same relation with our same and different color. Why? Because if you were to draw two marbles, it has one of two outcomes. It's either there are no green marbles, and what's opposite of no green marbles is that there are at least one green marble. So we can write on here 1 minus P, no green. And we have an answer from the previous question over here, no green. So it's just 1 minus 11 over 21, and it gives you 10 out of 21. Alright, that's it. Thank you so much for your time.